Hey guys, so in the last video, I said that you could use cotangent to theta equals a minus c over b. You can use that to find theta if you have a, b, and c, but I said that you could use it to find b if you had theta. Turns out that works in some cases, but not all. So I just want to show you kind of what happens if you try to just do that. If you try to not change A and C and just change B. And so I've solved this for B, where this is going to be our 2 theta in here. So right now I have it at 0, so this is just a regular ellipse, and then I'm going to rotate it, attempt to rotate it by just changing this theta. So I have this solved for B, and that's what's in here. So A is 3, C is 12, so 3 minus 12 is -9. And then if you solve this, you get -9 over cotangent 2 theta. If you're dividing by cotangent, that's the same thing as multiplying by tangent. So that's how I got this. Anyway, so let's actually try this out. So if I want a 30-degree rotation, let's just start with that. I'm going to put in 60 because remember that this is 2 theta. So yeah, that looks like a 30-degree rotation. Let's try a 60-degree rotation. So what if I put in 120? So I put in 120, that doesn't really look like 60 degrees. I'm not sure what that is, but it doesn't really look like 60 degrees. So I'm not sure exactly what I've done here, but it doesn't look like 60 degrees. I'm not sure what I've managed to do here. It's still an ellipse though. That's interesting. So it may have worked. That might be 60 degrees. It just doesn't look like it to me. So let's try something else. Let's try, what if I wanted 45 degrees? So what if I put in 90? Well, now I've turned it into a hyperbola. It does look like it's been rotated 45 degrees, but now it's a hyperbola. So that's interesting, right? I've changed an ellipse into a hyperbola by trying to rotate it. So it's not quite, that didn't quite work. Let's try going over 45 degrees. No, we did that already. I did 60. So let's try going to 90, rotating it by 90. Did something weird. So that doesn't even look like a hyperbola anymore. It might be. It might just be parallel lines though, because that can happen. If you're trying to rotate a conic, you can accidentally end up turning it into something that your book calls a degenerate conic. It just kind of collapses into something that isn't very useful anymore. You can look at the book if you want more details on that, but yeah, so it can collapse into something that's not really what we would consider a conic anymore. 18. Oh, that's interesting. So 18, which I would expect to just be a really small rotation, is actually a really big rotation. So yeah, so clearly this just trying to solve for B thing does not work. It doesn't work. It gives us all kinds of weird stuff. Interesting, but weird. Let's try doing one more. Let's try doing, so we did 180. Let's do something bigger than 180. So let's do 190. Okay, now I've made a hyperbola again. And I have no idea what the angle of rotation on that is. that looks more like negative 45 degrees. So yeah. Yep. So yeah, so you can't just solve for B. It does not work. You can get all kinds of crazy stuff. So that really doesn't work. We're not going to be doing that. Trying to get a certain angle anyway. But clearly, it's more complicated than just solving this for B. So that's interesting. Thought I would take a look at that since I said that in the last video and then I was second guessing myself. It's a good thing I second guessed myself because apparently that's completely wrong. You can't just solve for B. It seems like it would work, but it doesn't. Very interesting. Hope you guys found that interesting, and I will see you guys in the next video.